So it is no secret that the decline of the core region left many skilled tradesmen without a job. And in addition to that, you had a lot of workers in the industries that supported the coal industry that were looking to work, wondering what are we going to do now that the coal industry is declining. The Knox disaster really put the one of the last major nails in the coffin for the coal industry in northeast Pennsylvania. And Jude O'Donnell over at Anthracite Horror Stories, he did a great video, or actually more of an essay, on the decline in the 50s and the 60s. And that's worth checking out. And interestingly, corresponds with some of the trends I've seen in the drilling industry that supported the coal industry. Of course, drilling was used for the exploration side, and in some of the previous videos, I did touch a little bit on the geotechnical side of things. And many of the drilling contractors and firms in eastern Pennsylvania, when coal started to decline, they started to transition more into this geotechnical field, particularly for foundation samples. I came across this technical paper online covering the geotechnical investigation for the northeast extension of the Pennsylvania Turnpike. And if you're local to eastern Pennsylvania, no doubt that you've driven along this at some point. And this paper covers primarily use of core drills, auger drilling, and electrical resistivity testing, and how reliable and accurate is the information recovered from those three methods. The information was gathered over the length of about 1 year between 1954 and 1955, and this places it in the time period when we have the major highway construction happening in the United States and declined in the coal industry because it was only a couple of years later is when the Knox mine disaster happened. But as we could see from the graph before showing the employment of coal mine workers in the United States, there had been a steady decline since the 19 teens. It had been known since the 1920s that you could use a small diamond drill to take samples of soil and use information from that to estimate the bearing capacity of soil. For the last century, the split spoon sampler has been the backbone of soil investigations, and it was originally invented by Sprague and Hemwood out of Scranton, and later on, Acro-Drill made design changes to further improve it. So in the report, it specifies that 2-inch split spoons were used for soil sampling, while single tube core barrels were used for rock coring. In my core barrel videos, I cover single tube core barrels, but with a split spoon sampler, they call it a standard penetration test. You have a 140-pound weight dropped 30 inches onto your 2-inch sampler, and you count how many blows for every half a foot of penetration. And that correlates roughly to the density and bearing capacity of the soil. If the other methods employed indicated rock potentially above grade during the design phase, core drills would be brought in to core that rock. Now, the core drills, to get down to rock, they'd have to drive a 4-inch casing with a 300-pound hammer. And this used to actually be a standard. It would be 4-inch outside diameter casing, 300-pound hammer, 24-inch drop, and you count how many blows for each foot of penetration. Very similar to the split spoon sampling method, but now the casing blow count is an outdated practice. The previous page also indicates that split spoons were taken every 5 feet or at the change of material, which is still a fairly similar practice to the modern day. Here there is a schematic they provided, or diagram, of the diamond core drill used in this method. You can see a sketch of the drop hammer for casing or spoons in the core barrel in the ground inside the casing. The problem with augers is you can't take a sample of your rock unless you grind it up. So with that limitation, you would still need the ability to core that rock. And this was realized by the project managers at the time. With a core drill driving casing, when your casing stops driving, you just start coring. With an auger drill, you're going to have this violent shaking of your flights in your augers when you hit rock because you're trying to grind against it. However, the augers did have one advantage. They could move a lot faster than you could with a core drill. And to that extent, they could recover more information faster, but not as detailed information. The information recovered from the standard penetration test and rock coring was more valuable for locating the top of bedrock. So, what if you could take the advantages of both methods and then combine them together? In 1958, when this report was written, it was recommended that we should have special sampling augers developed specifically for soil sampling and equip them with drop hammers for taking your split spoon standard penetration test. And that would eliminate the need for water for cleaning out driving casing, and you'd be able to drill a lot faster and with a lot more mobility than the core drills at the time. And it's my hypothesis that the drilling firms of eastern Pennsylvania paid attention to this and took note of this, because in the early 60s is when we start seeing the development of the long stroke core drills that could also auger. And these machines, how they typically worked was the older machines were designed for coring and primarily coring. If you want a machine that could cut rock fast, that's what you want. These newer machines were supposed to be more general purpose. You had enough RPM on spindle where you could core rock, maybe not at the most optimal speed, but you could. You had torque, so you could run augers, and you were equipped with a cat head, so that way you could drive casing if you wanted, and be able to drive samplers. And the feed mechanism from the hydraulic drill head would work with push-type samplers like Shelby tubes. And this represents a larger shift in the drilling industry away from your diamond core drill exploration machines into the geotechnical market. Because you have the decline of coal mining, but then you have all these civil engineering projects coming up in the design phase, especially the highway projects. So you got other companies out west like Mobile Drill, CME, Dietrich Drill. They're coming up with geotechnical rigs. Meanwhile, in eastern Pennsylvania, Akra-Drill and Sprague and Henwood, they're trying to transition from making mineral exploration drills into making geotechnical rigs. So, how did they do? Well, Akra-Drill is still in business. They will still actually make, the old series of diamond drills, the spindle-driven series, like the Ace and the Hillbilly, and they're still in business. They're doing pretty good. And in their outer office, they actually have one of their original screw feed machines. They discontinued the contract drilling side of it around 1950, but they were still going strong into manufacturing. From what I'm told, the manufacturing and sales was a lot less headache for management than the contract drilling, especially with the decline in the coal industry. So what became of Sprague and Henwood? Well, they held on to the old methods, driving casing and drilling it in, and it wasn't until the 80s, some 20 odd years later, that they started introducing auger drills, and even then, those rigs were produced in small numbers. There are still some operational, and as far as I could tell, only 3 or 4 machines were made that would have been capable of running augers. And 2 of them I have, and one of them is actually up north being used for shallow water wells, actually. In both of these cases, we see the Pennsylvania drilling industry attempting to continue after the decline of coal. With some measure of success, Sprague and Henwood survived for 30 years after, and Akra-Drill survives to this day. So I would say that it is fairly successful in adapting to a change from having all of these mineral exploration contracts right in the area to having to focus on civil engineering.